For the video of this reading, I will read what is on the screen and then tell you when to pause and go answer the questions that are in your binder. So be aware that you can do that. You can also look for different questions in particular through the chapters near the description. Annual averages and variations. 50,000 years ago, the United States had much different weather patterns than those that exist today. The average temperature was several degrees cooler, and the jet stream was probably farther south. Understanding and predicting such climatic changes are the basic goals of climatology. Climatology is the study of Earth's climate and the factors that cause past, present, and future climatic changes. Climate describes the long-term weather patterns of an area. These patterns include much more than average weather conditions. Climate also describes annual variations of temperature, precipitation, wind, and other weather features. Studies of climate show extreme fluctuations of these variables over time. For example, climatic data can indicate the warmest and coldest temperatures recorded for a location. This type of information, combined with comparisons between recent conditions and long-term averages, is useful to businesses that are deciding where to build new facilities and to people who have medical conditions that require them to live in certain climates. Climate data include the warmest and coldest temperatures recorded for a location. The highest temperature on record for Chicago, Illinois is 41 degrees Celsius, or 105.8 degrees Fahrenheit, which occurred in July 1934. The lowest temperature on record for Chicago, Illinois is negative 33 degrees Celsius, or negative 27.4 degrees Fahrenheit, which occurred in January 1985. Pause this video and go answer question number 1 on page 12 in your science notebook. Normals. The data used to describe an area's climate are compiled into meteorological records, which are continuously gathered at thousands of locations around the world. These data include daily high and low temperatures, amounts of rainfall, wind speed and direction, humidity, and air pressure. The data are averaged on a monthly or annual basis for a period of at least 30 years to determine the normals, which are the standard values for a location. In the table on the right, we can see the monthly temperature summary for Minneapolis, Minnesota. So these are our normals for temperature. So January, our average maximum is 24 degrees Fahrenheit, and our average minimum is 8 degrees Fahrenheit. You can look at the rest of the table to see how those normals change throughout the months. And then go ahead and pause and go answer question number 2 on page 12 in your science notebook. Contrasting changes in weather. While normals offer valuable information, they must be used with caution. Weather conditions on any given day might differ widely from normals. For instance, the normal high temperature in January for a city might be 32 degrees Fahrenheit. However, it is possible that no single day in January had a high of exactly 32 degrees Fahrenheit. Normals are not intended to describe typical weather conditions. They are the average values over a long period of time. While climate describes the average weather conditions for a region, normals apply only using the specific place where the meteorological data were collected. Most meteorological data are gathered at airports, which cannot operate without up-to-date, accurate weather information. However, many airports are located outside city limits. When climatic normals are based on airport data, they might differ from actual climatic conditions in nearby cities. Changes in elevation and other factors, such as proximity to large bodies of water, can cause climates to vary. Pause and go answer question number 3 on page 12 in your science notebook. Causes of climate. You probably know from watching national weather reports that climates around the country vary greatly. For example, on average, daily temperatures are much warmer in Dallas, Texas than in Minneapolis, Minnesota. There are several reasons for such climatic variations, including differences in latitude, topography, proximity to lakes and oceans, availability of moisture, global wind patterns, ocean currents, and air masses. On these graphs, you can see the low and high temperatures represented by the kind of black and red lines respectively, and then precipitation by the blue bars for Dallas, Texas, and Minneapolis, Minnesota through the course of a year. As you see, the high and low for Minneapolis are lower than that in Dallas. And our precipitation kind of goes with our high and low temperatures, whereas it doesn't quite follow the same pattern in Dallas, Texas. Latitude. Recall that different parts of Earth receive different amounts of solar radiation. The amount of solar radiation by any one place varies because Earth is tilted on its axis, and this affects how the sun's rays strike Earth's surface. The area between 23.5 degrees south and 23.5 degrees north of the equator is known as the tropics. As the diagram shows, typical tropical areas receive the most solar radiation because the Earth's rays are nearly perpendicular to Earth's surface. As you might expect, temperatures in the tropics are generally warm year-round. For example, Caracas, Venezuela, located at about 10 degrees north, enjoys average maximum temperatures between 24 degrees Celsius and 27 degrees Celsius year-round. The temperate zones lie between 23.5 degrees and 66.5 degrees north and south of the equator. As their name implies, temperatures in these regions are moderate. The polar zones are located from 66.5 degrees north and south of the equator to the poles. Solar radiation strikes the polar zones at a low angle. Thus, polar temperatures tend to be cold. Thule, Greenland, located at 77 degrees north, has average maximum temperatures between negative 20 degrees Celsius and 8 degrees Celsius year-round. In our picture, we can see how sunlight is hitting different parts of our Earth. Here in our tropical zone, we see sunlight is hitting almost at a perfect 90 degrees, much more direct. In our temperate zones, like we have here in Minnesota, it's hitting at about a 45-degree angle, so it's a bit more spread out, less intense. And finally, at the polar zones, it's hitting at about a 30-degree angle, the most spread out of any of the parts on our Earth. Please pause and go answer question number 4 on page 12 in your science notebook. Topographic effects. Water heats up and cools down more slowly than land. Thus, large bodies of water affect the climates of coastal areas. Many coastal regions are warmer in the winter and cooler in the summer than inland areas at similar latitudes. Also, temperatures in the lower atmosphere generally decrease with altitude. Thus, mountain climates are usually cooler than those at sea level. In addition, climates often differ on either side of a mountain. Air rises up one side of a mountain as a result of orographic lifting. The rising air cools, condenses, and drops its moisture, as shown by the diagram. The climate on this side of the mountain, the windward side, is usually wet and cool. On the opposite side of the mountain, the leeward side, the air is drier and it warms as it descends. For this reason, deserts are commonly on the leeward side of mountains. Here in our picture, we can see a mountain, and we have wind direction coming off of the ocean, and we have the windward side, which is cool and wet. Here's kind of a picture of what that might look like. We get moist air rising causing these clouds and the moisture to condense and then rain. As air on the windward side of a mountain rises and cools, it condenses and precipitation occurs. Then over here on the leeward side, it's supposed to be warm and dry, and it might look more like this. We have potentially snow at the top and then dry air coming down. And it says dry air warms as it descends the leeward side of a mountain, commonly resulting in desert conditions. At this point, please pause and go answer question number 5 on page 13 in your science notebook. Air masses. 2 of the main causes of weather are the movement and interaction of air masses. Air masses also affect climate. Air masses have distinct regions of origin, caused primarily by differences in the amount of solar radiation. The properties of air masses also depend on whether they formed over land or water. The air masses commonly found over North America are shown on the map below. Up here in northern Canada, we have continental Arctic, CA, which is very cold and dry air. That's that air mass. In kind of central Canada, we have the continental polar, CP, which is also cold and dry, but not quite as cold as the Arctic. On the left, we have maritime polar, which is cool and moist air. And on the right, we also have maritime polar, again, that cool and moist air. Down here in kind of southwest United States and northern Mexico, we get the continental tropical, which is going to be hot and dry air. And then in the south, to the left and right, we have maritime tropical, which is warm and moist air masses. Average weather conditions in and near regions of air mass formation are similar to those exhibited by the air masses themselves. For example, consider the island of Dominica, shown in the photo below, in the tropical Atlantic Ocean. Because this island is located in an area where maritime tropical, MT air masses dominate, the island's climate has maritime tropical characteristics, such as warm temperatures, high humidity, and high amounts of precipitation. Here's that picture we referenced. And it says air masses affect regional climates by transporting the temperature and humidity of their source regions. The warm and humid maritime tropical air mass supports lush vegetation on the island of Dominica. Go ahead, pause, and answer question number 6 on page 13 in your science notebook. And that is it for this reading assignment.